Sugary drinks have long had a reputation for being guilty pleasures, indulgences we enjoy without much thought beyond calories or sugar crashes. But the latest research in Nature Metabolism reveals that these beverages may have a far more profound effect at the microscopic level than we ever imagined. Central to this story is an enzyme called SORD, which acts like a hidden accelerator inside our cells, transforming ordinary sugar into a potent driver that cancer cells can exploit. In essence, what seems like a harmless soda may, under certain conditions, fuel a machine that empowers cancer to spread. To visualize this, imagine your cells as a bustling city. Each cell has a role, from keeping traffic flowing to maintaining infrastructure, and everything is coordinated to keep the city running smoothly. Cancer cells, however, are like rogue vehicles attempting to hijack the system, and they need fuel to break free from their normal boundaries. This is where SORD comes in. Normally, it's a quiet worker, processing fructose and glucose efficiently, like a reliable engine in a public transport system. When sugary drinks flood the system with excess sugar, SORD ramps up, converting that influx into a turbocharged fuel source. The cancer cells seize the opportunity, using this energy to move faster, adapt, and metastasize, spreading from their original neighborhood to other parts of the body. What was once a calm, orderly city is suddenly faced with high-speed traffic controlled by the wrong drivers. Yet the story here is far from hopeless. In fact, it carries a strong message of hope and empowerment. By identifying the precise role of SORD, scientists now have a clear target for potential interventions. If cancer cells rely on this enzyme to turn sugar into a metastasis machine, then therapies can be developed to slow down, regulate, or block SORD's activity, effectively grounding the cancer cells before they spread. This turns a molecular villain into a controlled pathway that researchers can study, manipulate, and ultimately use to improve patient outcomes. The insight gives hope for more precise, smarter treatment strategies in the future, ones that focus not just on attacking tumors directly, but on depriving them of the resources they need to thrive. Even outside clinical settings, the study provides a practical takeaway for everyday life. Understanding SORD's role highlights why reducing sugary drinks isn't just a dietary suggestion, it's an actionable way to limit the fuel available to cancer cells. Every time someone opts for water, unsweetened tea, or even a piece of whole fruit instead of a soda, they're taking a small but significant step to interfere with this molecular engine. The act of moderation or substitution becomes a proactive, tangible defense against a potential risk. What's also encouraging is that this research deepens our understanding of cancer without creating panic. SORD itself is not inherently bad. It's a normal part of metabolism that only becomes problematic in the presence of excess sugar and cancerous conditions. This nuance is empowering because it shows that the body is not a passive victim. Awareness, knowledge, and informed choices can make a meaningful difference. It's a reminder that science is about understanding context, mechanisms, and opportunities for intervention rather than simply labeling something as dangerous. Ultimately, the study transforms the narrative around sugar and cancer. What could have been a vague or frightening warning, "Too much sugar is bad," becomes a precise, actionable insight. SORD is no longer a hidden enzyme quietly assisting cancer. It is a clearly defined pathway that researchers can target and individuals can influence through lifestyle choices. This turns a scary concept into a story of empowerment, knowledge, and hope, where science equips us to defend our bodies and reduce risk. What seemed like a silent threat is now a revealed mechanism, giving us both understanding and the tools to act, transforming fear into opportunity and awareness into prevention.